Now consider an example in which we're going to practice computing the consumer surplus for a specific experience utility function. The goal of the example is both to help you practice the computation, but also to give you confidence that the equivalent ways that we have identified of computing the consumer surplus actually lead to the same answer. So the example that we're going to look at is for the utility function that we have seen before that has the shape to the utility of x, and the amount of m is 2a square root of x plus m. Let me remind you from derivations in previous videos that the marginal benefit function for this case is just given by a over square root of x, and that the demand function for this case, x of p, is a squared divided by p squared. Now let's compute the consumer surplus in two different ways. First, we're just going to apply the definition. I'm going to call that the direct approach. Just apply the definition. And we know that the consumer surplus at P is going to be equal to the utility after the trade. So the utility, let's say, at the amount demanded at price P minus the utility at no trade. So that before. So that is going to be equal, just substituting, to 2a square root of the amount that is demanded plus the wealth of the consumer minus the amount that gets spent to buy the optimal quantity. So that is the utility at the trade minus the utility at the no trade, which is just basically 0 because no x gets consumed, plus w because everything gets consumed in the good m. Now the wealth cancels in both cases, and what we get substituting the definition of the optimal demand is that this is equal to 2a squared divided by p minus a squared p squared times p, and this is just equal to a squared over p. So we have derived that for any price p, the consumer surplus is a squared over p. And as always, let's check our economic intuition. It makes a lot of sense. The more valuable the good is, the more valuable the trade is. The more expensive the price of the good, the less valuable the trade, the less the consumer surplus is. Now, let's compute the consumer surplus using the graphical or integral approach. These are equivalent, as we have seen. And to remind you, think of the plot that has x here, has the marginal curve here, and at any price p, we know that the amount that we're going to demand is x star of p, and this is going to be equal to a squared over p squared. Now, we know that the consumer surplus is going to be given by this area. We saw that before. So let's compute what that area is. The consumer surplus at P is going to be equal to the integral from 0 to the amount demanded, so from 0 to a squared divided by p squared, under the marginal benefit function, which is given by this, and above the price P line, so over the function a divided by square root of x, that's the marginal benefit, minus p dx. Now this is equal to, if you solve the integral, which I am just going to write the solution for you, 2a x to the 1/2 minus px evaluated between 0 and a squared over p squared. If you do the substitution, you get that this is equal to a squared over p again. So this is very nice. It doesn't really matter whether we compute the consumer surplus through direct substitution, which is the right and easiest way of doing it in some cases, or whether we compute the area, the relevant area under the curve. Both solutions, both ways of approaching the problem should give us the same answer as demonstrated in this example.